So welcome to this latest video 162 Math, and in this video we'll be going over some past GCSE exam questions related to angles in a polygon. Now as always, I'll include a copy of the test questions that we go through in this video as a link in the description below, along with any lessons that cover this topic in greater detail. Now before we get started working through some past exam questions, let's just have a quick overview over what it is you need to revise for this particular topic. So the first thing is you need to know the names of polygons and their number of sides. So in other words, you need to know that you've got triangle has got 3 sides, quadrilateral has got 4, in which there are many quadrilaterals that you can have. You've got pentagon, which has got 5, hexagon, which has got 6, a heptagon, which has got 7, octagon, that's got 8, a nonagon, that's got 9, a decagon's got 10, and a dodecagon, which has got 12. Don't worry about the 11, that's quite rare for it to come up, but the others you do need to know. Now obviously knowing the interior angles does help, but there is a formula which you can work that out. Now the next thing you need to know is what the word regular means. Now regular is really important when tackling these questions, but basically the word regular means that all the sides and all the interior angles are going to be equal, which is going to be really important whenever you work with any angle question, is to look out for that word regular, because it will make the question seem a lot easier to do. You also need to know what the difference is between an interior angle and an exterior angle. Now, interior angle is quite self-explanatory. It's the angle inside the shape at one end of the vertex. However, the exterior angle, now most people do get confused with this, is because when you think exterior, you think outside. So automatically, if I pick this point here, you may think it's this angle here is the exterior, when actually that's not the exterior angle. The exterior angle is the straight line with the exterior angle, and it's the exterior angle that's this bit here that joins the interior angle at a 880 degree angle. Now obviously one way to look at it is like a Catherine wheel. So for example, if that's there, then that's going to be there, 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 and then you've got this angle here. And all of these are going to be your exterior angle of this particular hexagon. So make sure you recognize what the exterior angle is, and make sure that you recognize that it's on a straight line with the interior angle. The next thing you then need to know is how to find the total sum of angles in a polygon. Now all the formulas that you need to know, which are not given in the exam, these are formulas that you need to know, are here. Now obviously you can learn these formulas like a spelling test, or you can really understand the question, the actual formula, and then hopefully once that's sunk in, you can then work out how to work out the interior angle, the exterior, or the total sum of angles without having to use a formula. You just know how to do it. So the total sum of angles is 180 multiplied by n minus 2, where n is the number of sides. Now in other words, this is basically the number of triangles inside the shape multiplied by 180, because all the angles inside a triangle is 180. The next thing is the interior angle. So to work out the interior angle, what you've got to do is work out the total sum of angles, which is the formula of 180 multiplied by n minus 2, and then you divide that by the number of sides, and that'll tell you what the interior angle of a regular polygon is going to be. Now remember that irregular polygons will have different angles, so again you can't use that formula. However, you can use the formula for the total sum of angles in a polygon, because it doesn't matter what type of variation of the polygon it is, the total sum of angles will always be the same. So in a quadrilateral, doesn't matter whether you've got trapezium, parallelogram, all the interior angles added up together will equal 360. The next thing you then need to know is the exterior angle. Now the exterior angles, basically all the exterior angles added together equal 360. So to work out the exterior angle of any polygon, or regular polygon I should say, you need to do 360 divided by the total number of sides. Now other questions that could get asked are basically reverse questions, where you are given the interior angle and you need to work out what the number of sides are, in which you can use the same formulas, but you just need to rearrange the formula or solve the formula for n. Now before we get started, a little reminder that if you're wanting access to these questions, all you need to do is just simply click on the link in the description. So looking at question 1, it says that a regular decagon, a 10-sided shape, is drawn below. And question 1a is asking us to work out the size of the exterior angle. Now just bear in mind that there's always more than one way of working out the answer, so as long as you show working out and you get the right answer, it's all good. So looking at this, we can know that all exterior angles add up to 360. So if I divide that by the number of sides, which is 10, That gives me an answer of 36 degrees. So the exterior angle is 36 degrees. Then to work out the interior angle, well, I know that the interior angle plus the exterior angle are on a straight line. So then if I want to work out the interior angle, I've just got to do 180 minus the exterior angle, which is 180 minus 36, which gives me an answer of 144. Then for 1C, it says work out the sum of the interior angles of a decagon. So we want to work out the sum, not one interior angle. So it's going to be, we can either do 180 multiplied by 10 minus 2, or I know that one angle is 144, and I know that there's 10 angles altogether, but either way, I should have the answer of 1440. Moving on to question 2a, it says work out the size of an exterior angle of a regular hexagon. Now a hexagon has got 6 sides. Oh, don't know what happened there. It's got 6 sides, so then all I need to do is 360 divided by 6, which gives me an answer of 60. It then says work out the size of an interior angle. Well, that's just going to be, well, again, the interior angle is 360, or is it 180 rather, minus the exterior angle. So it's going to be 180 minus 60, which is 120. Question 3, it says that a regular pentagon has 20 sides. Work out the sum of the interior angles. So it's going to be 180 multiplied by 20 minus 2. So then type that into my calculator. It's going to be 180 times 18, which gives me an answer of 3,240. It then says work out the size of one of the interior angles. Well, for this, all I need to do is do the total sum divided by how many angles there are in this shape was a 20-sided shape, so divide that by 20 and I get the answer of 162. Then moving on to question 4, it says that a regular polygon has 24 sides. Calculate the size of each interior angle. So for this, what I need to do first is work out the total sum. So for this, I can do 180 and it's going to be 24 minus 2, all divided by the total number of sides, which is 24. Alternately, what you could also do is do 360 divided by 24, and that gives me an answer of 15, and that's the size of an exterior angle. So then to work out the interior angle, it's going to be 180 minus 15, and either calculation will give me the correct answer of 165. Moving on to question 5, it says explain why this cannot be an interior angle of a regular polygon. Well, for this, if the interior angle equals 152, then the exterior angle will equal 180 minus 152, which equals 28 degrees. Now 28 is not a factor of 360, so this is not a regular polygon. You could also say with this line here, you could also say 360 divided by 28 is not an integer, because obviously that calculation needs to give you how many sides there are, and again, if I was to work this out on my calculator, 360 divided by 28 gives me an answer of 12.857, so it's not an integer, so not a regular polygon. Moving on to question 6, it says that a regular pentagon and a regular octagon have sides of the same length. A pentagon is drawn inside the octagon as shown, and the question is asking us to work out the size of angle X. Now angle X is equal to the interior angle of the octagon minus the interior angle of the pentagon. So what I need to do is I need to work out these two things first. So here the interior angle of the octagon is going to be, well, again, you can use either calculation. So you can do 180, 8 minus 2, all divided by 8, and that gives me an answer of 135. Alternately, you could have done 360 divided by 8, and then which is 45, and then do 180 minus 45, which equals 135. So again, either way, it's entirely up to you. Then we need to work out the interior angle of a pentagon, which is going to be, and again I'll do this method, so 360 divided by 5 equals 72, and then 180 minus 72 equals 108. So the interior angle of a pentagon is 108 degrees. So then to work out x, it's going to be 135 minus 108, which gives me an answer of 27 degrees. Then moving on to question 7, it says the sum of angles in any quadrilateral is 360. For example, in a rectangle, 4 times 90 equals 360. Christopher writes 6 times 90 equals 540. So the sum of angles in a hexagon must be 540. And the question's asking, is he correct? Well, the answer is going to be no. Now, there's a couple of reasons which we could write. And again, remember that your answer for no needs to be backed up with a correct reason. If you just tick no, you're not going to get 1 mark. So make sure you're writing a valid reason. So you could say something along the lines of that a hexagon cannot have 6 90-degree angles. You could also say something along the lines of that a hexagon has 6 obtuse angles. You could also say something along the lines of that the maximum number of right angles in a hexagon is 5. And also what you could also do is draw a hexagon and show he is incorrect. So any of those 4 would be valid to get your 1 mark explanation. So for question 8, it says part of a regular polygon has 18 sides as shown, and the question is asking us to work out the size of an interior angle. So again, one method is to use the total sum of angles, then divide by 18. But if I do the exterior angle, which is going to be 360 divided by 18, which gives me 20. So that means that the interior angle is going to equal 180 minus 20, which is 160. And again, if I did the other method, it would be 180 multiplied by, how many sides were there? 18. So it would be 18 minus 2, all divided by 18, in which I'd get the same answer. Moving on to question 9, it says that 2 congruent regular polygons are joined together. Work out the number of sides of each polygon. Well, for this, we know that we can work out the exterior angle, which is this angle here, which is 24. So if I then do 360 divided by 24, that gives me an answer of 15. So that means that there are 15 sides. Then moving on to question 10, it says that AB, BC, CD, DE and EF are 5 sides of a regular 12-sided dodecagon. What is the size of angle X? So for this, the first thing I need to do is work out the interior angle of a dodecagon. So this is going to be 180 multiplied by 12 minus 2, all divided by 12, and that gives me an answer of 150 degrees. So that means that this angle here is 150, that's 150, that's 150, and that is 150. Now the total sum of angles in a hexagon, which is what this shape here is, because it's got 6 sides, is going to be 180 multiplied by 6, take away 2, which gives me an answer of 720. So then if I add up all of those 6 angles together, so this one, this one, this one, this one, this one, this one, and this one, I get an answer of 2x plus 600 equals 720. So 2x equals 120, so x is going to equal 60 degrees. Then moving on to question 11, it says 2 regular polygons are shown below. Polygon A has 12 sides and an exterior angle of 5x. Polygon B has n sides and an exterior angle of 3x. Work out the value of n. So for this, what we need to do is, let me just zoom out so I've got a bit more space to write, as this is a 4-mark question. So first of all, let's work out what the exterior angle of polygon A is going to equal. So the exterior angle, because we know how many sides it's got 12, so it's going to be 360 divided by 12, which gives me an answer of 30 degrees. So that means that 5x equals 30, so x must equal 6 degrees. So then I can then work out polygon B. So polygon B, the exterior angle is equal to 3x, which equals 3 times 6, which is 18 degrees. So then to work out the number of sides on polygon B, it's going to be 360 divided by 18, which gives me an answer of 20 sides. So the answer then for n is 20. Then moving on to question 12, it says that the diagram shows a regular hexagon ABCDEF and a square DEGH. And it says the lines CD and DH are sides of the same regular polygon C. Work out the number of sides of polygon C. So let's have a look at what we know. So we know that this angle here is 90 degrees. And we can work out what this angle here is, as that is a regular interior angle of a hexagon. So this angle here is going to be 180 multiplied by 6, take away 2, all divided by 6. And I get that as an answer of 120 degrees. So then I can then work out what this angle here is going to be by doing 360 minus 120 minus 90, which equals 150 degrees. So then to work out the exterior angle, that's going to be 180 minus 150, which is 30. So then to work out the number of sides, it's going to be 360 divided by 30, which gives me an answer of 12 sides. Then moving on to our last question, it says that a regular decagon and a regular pentagon have sides of the same length. They are joined as shown, and it says prove ABC is in a straight line. So first of all, let's work out what this angle here is going to be. So to work out this is a decagon, so it's going to be 180, 10 minus 2 divided by 10, which gives me an answer of 144. So that angle there is 144. I can then work out what this angle here is by doing 180, take away by 5 minus 2, which is 3, divided by 5, and that gives me an answer of 108 degrees. Now, if ABC is on a straight line, then ABC equals 180 degrees. So, and ABC is equal to ABD plus DBC. So what I need to do is I need to work out what this angle here is, and I also need to work out what this angle here is. Now I know from the diagram that this angle here is 144. So ABD is equal to 144. Now to work out this angle here, let me just use a different colour. What have I not used? Orange. So to work out this angle here, that's going to be 360 minus 144 minus 108, which equals 108 degrees. Now triangle DBC, this angle here is 108, and this triangle is an isosceles triangle. How do I know? Because it says that those lengths are equal. So then to work out this angle here, I've got to do 180, take away 108, divided by 2, and that gives me an answer of 36 degrees. So angle DBC is equal to 36 degrees. So as ABD plus DBC equals 144 plus 36, which equals 180, A, B, C lie on a straight line. And there we go.